Video number 11 of Akula, Roman Karnukhov, citizen of Kazakhstan, former Republic of Russia. I have had a discussion with him a few days ago, and actually it was the same. I was talking about my proceeding with Coleman, he was talking with his proceeding with his Akula device, and I was pushing on giving the apparent manual for everybody to be able to repeat it. But we had a very friendly discussion, and I would like to say my great thank you to Roman. Роман, большое спасибо тебе за твое видео и за разговор, который мы с собой имели. Еще раз, большое спасибо. Okay, what he's gonna do in here is he's gonna show a configuration that is made out of two coils. On the right hand side, you're gonna see the Tesla coil with a capacitor on the top of it. And on the left hand side, you will see the structure that usually is being seen as a bifilar coil plus the pickup coil. The wires that you see at the bottom on the left hand side would be the wires that are connected to two light bulbs of 1 kilowatt each one, and plus addition to the third one, which would be 500 watts. So let's go to the video.
Так, но смысла самого проверять я не вижу. Просто теория, которая понятна фактически так, что она работать будет.
I don't see any reason for me to explain too much. There's only theory that will turns out to state for the fact that this device is working.
Так, две по киловатту, одна 500 ваттная.
Two labels, 1
Просто
kilowatt
на
each
вторичку,
one,
на съем,
and 500 watts each.
заземление.
We have one wire of the ground wire. I gotta come back to that.
Так, постараюсь амперметр показать в работе. Просто на вторичку.
Okay, so we have two wires. Those wires are connected to the pickup coil that is on the top. If we look further, there is one wire, this wire, and that's the ground wire. So that's the ground wire. This wire is not connected to these two wires. And then we have two wires, one here, one over there. Those wires are connected here. And we have actually, those two wires are connected to this one, and this thicker one is connected here. And those are for the load, which is the light bulbs.
Заземление.
Ground wire, again.
Так, постараюсь амперметр показать в работе.
And this amp meter will show you the current that is flowing through the primary Tesla coil. That would be, Tesla coil is made out of two coils, one at the bottom of the structure and one the top one. If we have ratio 1 to 10, means 1 wind on the primary, 10 on the secondary, would that definitely give us, for every volt delivered to the primary, times 10 volts on secondary? Yes, it would. So let's say we have ratio 1 to 1000. For each wind on the primary, we have a 1000 on the secondary. If we deliver 1 volt to the primary, we're going to have 1000 volts at the secondary. That's how the transformer works. But we don't have any, separate anything between those two coils. It's an air. Later on, I'm going to give you the air breakdown, but there's also another factor, which is the permeability. And the permeability of air is 1. And he also states that that amp meter is a kind of insensitive, so you're not going to see much on it. But it is important for us to know that the power permeability is the measure of the ability of the material to support formation of magnetic field within itself. So you could say the degree of magnetization that the material obtains is in a response to an applied magnetic field. And magnetic permeability is typically known as mu, but let's go further. So far we see close to 0 amp. We don't know what is the voltage.
Но по нему мало чего видно, потому что он тубовый.
He says that you might not see too much from that ammeter because this ammeter is not so sensitive.
Так, точно так же в Тесле подходит заземление и питание.
Okay, we have one wire which is a ground wire, so the white wire I assume is the ground wire, and the black wire is a voltage that is supplied from 200 to 20 volt. Let's see if I'm right.
220.
Yes, I am right. Okay, so you see that wire here that goes and is connected to the power strip. Actually, no, it's connected here.
Поехали.
Okay, this is it. This is the wire.
Включаем нашу Теслу.
We are starting our Tesla coil. Since the coil didn't tell us what is the voltage on the top of the coil, we need to use the alternative method for it. That's why we need this table, which error shows 20 to 75,000 volts per inch required. And if we go to mica, and mica would be the last one, we need 5,000 kilovolt per inch to create a breakdown, which would be the spark. To understand it better, the atoms in insulating material have very tightly bound electrons, resisting free electrons flow very well, and insulators cannot resist voltage applied at infinite amounts. So with enough voltage applied, any insulating material will eventually succumb to electrical pressure and electron flow will happen. However, unlike the situation with the conductors where the current is in a linear proportion to applied voltage, means given a fixed resistance, the current through the insulation is quite nonlinear. So for the voltages below the certain thresholds level, virtually no electrons will flow. But if the voltage exceeds the thresholds, then it will be a rush current, and then we're gonna have a breakdown, which is the spark jumping out. Once that happened, the insulating material no longer reacts as an insulator. With the air as an addition, we have a creation of the conductive pipe due to the ionization factor that will decrease the voltage, sustaining continuity of the spark. And that may decrease the required voltage quite significantly, up to 70% of its value. As a part of additional information education, I need to give you Arona's principles. Aronas is a very bright person from England, a friend of mine, and there was him who implemented that method in Lithuania experiment where I was assisting, and we were able to achieve 1 kilowatt at the end of it, driven from milliwatts after the losses, but the total drawing from the grid was about 10 watts for 2 signal generators. And then I'm gonna use a part of the video that was done some time ago. You can find it on my channel, and you see the title on the top of the picture frame. That is Wake Up Another How FE Works, video number 1. You can go to it and you can understand more about that's what I'm talking about. Thank you for now, and let's go to it. You see in here the signal, and I'm gonna show you the same one over there. This is where you start, exactly at the 0 point. You're putting the peaks on it all the way to the top. 3% before the very top, you stopping it, and you can repeat it in the opposite side of the sinusoid, but you never give the signals from the very top to 0.
So now we're dealing with the acceleration of the Y spin nuclear magnetic resonance. The magnetic field creates the electromagnetic force in the plasma, like it would create in a coil. The current that is flowing because of that influence is reacting as accelerating force. So let's say we have a hammer and hammer is on the shelf, and instead of just sliding the hammer from the shelf gently to the table, we decided that the 10 kilograms hammer is dropped. Now we have a force that would possibly break the table. That is a very similar to the hammering effect that is happening in plasma. So at X part, we have acceleration x2 more, x3 more, and then on the right hand side, we have all of these effects added. So now, we're opening the switch on the left hand side, we're closing on the right hand side, we are right before the maximum of the impulse, we send the information immediately, as the static cannot be 3/4 on the left hand side and 1/4 on the right hand side. Static is immediate. We now build magnetic fields. All of the components and impurities of the spark gap with all of the harmonic frequencies that were created due to creation of the spark, now influencing the magnetic field that is in between the plates of the capacitor. I remind again that by tuning a distance between the plates of the capacitor, we're tuning the circuitry to the self-resonance of the spark gap. Then we create a current in the conductive medium, and we repeat a hammering effect again. Do have a dissipation of energy, and we do have losses in here, but we just assume that the amount of energy on the right hand side at the highest peak still represents a significant difference of potential. Capacitor mentioned in this video does not necessarily look like a typical two-phase capacitor.
So let's come back to Akula's video number 11. Those two coils structures, one in here and one over there, those are two plates of the capacitor that I have described. And then you're gonna have a spark on the top. But also we're dealing with the capacitive reactance or coil capacitor sort of between the primary of the Tesla coil and the secondary of the Tesla coil. And on the top of it we have we call it capacitor, but actually it's the reactive element or connected to the upper part of the Tesla coil, right to the wire coming from the top to here. Now on that side we see a coil, and then we see the pickup coil here, right? So that was explained in the previous videos. So we have a B-filler, we have a pickup coil, and then we should have a load connected to the pickup coil by itself. There is another story also, which is the wire that is supposed to be inside with the heavy rod. With this part is omitted right now in the Akula device. Did he do it on purpose, or he simply was trying to wrap it up? We don't know that. Let's go to the video back when he's starting the device.
Включаем нашу Теслу.
Okay, he's connecting,
Теперь главное совместить частоты.
and he says now it's important to tune the device to the particular frequency. He doesn't show on this video exactly how he's doing the tuning, but we know from the previous videos. So he's actually adjusting the frequency of the generator that is connected to the primary, to the Tesla coil on the right, the primary winding of it. And then you see two light bulbs of 1 kilowatt at 30% of its power on. And you can use a simple calculation: power equals current times voltage. And we can also go with the E squared times R, which would be the resistance equals power. Whichever one we want to take, we don't know a certain thing, so at least we don't know the resistance, but you could look at the catalog, find what is the temperature and the resistance of the light bulb, and we want to have a calculation for the parallel connection that will come to 333 volts per light bulb. If we go with the parallel connection, then we'll see that it's 666, but the current is divided by 2. So then we will have approximately 1.5 amp per light bulb. Now, we know that the light bulb is 1 kilowatt each one of them. So I see certain inconsistencies unless we're talking about not full brightness. Okay, now we see the distance is 1, 2, 3, 4, 5, approximately 5 inches, 5 times 2.5 centimeters. It would be 12.5, 13 centimeters of a distance. For the spark, the breakdown of the dielectric constant of the air, the minimum with the high humidity, we should say at the beginning of is 20 kilovolts, but then it jumps down 70%. So you could see, in order for sustaining the motion. As unbelievable as it sounds, we need 1000 volts. Okay. Now, if we talk about the capacitive reactance of the dual coil on the right hand side of the Tesla, we're talking about accumulation of the charge. So not necessarily the voltage on the right hand side could be 20,000 volts. That might be misleading. It's like a fully charged capacitor. You need just one charge, and then after you ionize that medium, you don't need much. With the calculation, I would say I'm not fully in belief to that. I would say we're probably about 7 to 8 kilovolts. And I've been doing this kind of experiment also, quite enough. Now, since we derive with the voltage, we can go further with that. So he's hearing right now, and we see right now another one, which is a 500 watts connected. You guys will look a little bit more careful to find out how he connected light bulbs. Either all of them are in series or they're in parallel, because I didn't see that. I was rather trying to concentrate on the basic principles. Now we see in here that the current is close to, if it's 5 in here, then we have about 200 milliamps on the meter. Guess what, guys? The doubt that I have, and I have it, is not because I don't believe that the Aqua device works. I believe that it works. But this kind of a amp meter might work till the certain frequencies, and then it will no longer show the truth. Роман, если будет возможно, пожалуйста, если ты можешь взять с любого передатчика бывшего военного ампметр, который есть на РФ, здесь видишь, какой типы работают. Я уже не хочу просто терять времени, слишком долго это берет, просто объяснять все это. Но спасибо тебе большое, все такое. Okay, so I have explained to Akua what should he use in order to minimize all of the doubts, as we don't want to deal with second capenaza. I believe Akua is trying at one hand attract us. Like everybody else, he wants to make money on it. There's nothing wrong with it. Only that there is a significant difference between me and him. I'm for the humanity and I'm not for the money. I want to make money, but on equal basis. And I don't really divide people on the bad one and the good one. I don't give a damn about it. So that's what we need to have done. Now, what is important here, he shows 4.29. So now we assume that since we have a 2.5 kilowatts of power on the light bulbs, that's what he's showing us is the one leg current. Now, of course, we need, if somebody wants to look carefully, just tired today, to see how he connects the light bulbs. Unit T. What is important for you to guys find out, didn't really do that yet.
T241 digital power clamp. Now, first off, I owe a big thanks to Barry of tester.co.uk who sent this to me for review.
You gotta go to this one. It's I'm gonna go further with that so you could see that. That's the review unit TUT241 power clamp meter by gentleman on YouTube, Milton.
Besides doing power measurements, you can do power quality measurements. So you can measure the harmonics on your AC signal. You can also measure power factor, apparent power, real power. And that's important because if engineers are trying to design an electrical system, what happens is if you have an inductive load or a capacitive load, so let's say you have a motor that starts up, that will take the voltage and the current in your AC power out of phase. Now,
So it looks like Akula could give us a little bit more information, although this is a very much primitive version of the same type of it, and we at first need to know what is the maximum frequency of operation. As we know, Akua stated that some of his devices work at 10 kilohertz, but up to 60 kilohertz. So if he has the capability, at least we would expect him to put that clamp on the incoming wire from the grid to give us the reading instead of just unknown nature amp meter. Пожалуйста, если будет возможно, это поможет. So that's the update that we have in here. I mean, what was the problem? Just put it the clamp on that wire. Not a big deal. Okay, guys, thank you very much for your attention. It took me a little bit longer to explain, but I wanted really to do it more or less not only for very much advanced members of Over Unity or Free Energy movement. You gotta understand, free energy is the energy that is free of charge, but energy must come from somewhere and be utilized by us or converted to usable form of the energy. This is the channel of Wesley, Wesley, and the YouTube channel is Stevep1, STIVEP1. I wish you the best and have a good night. And New York time is 21:32 military time. Thank you very much. Спасибо большое.